All right, 4.7 inverse trig functions. What's an inverse? It's a what?
Switch X and Y.
You guys are quick. All right, so we're going to switch x and y. All right, and inverse and arc mean the same thing on these little trig functions, but that's really what's happening. All right, so if I have y equals sine x, if I switch x and y and solve for y, I end up getting arc sine. All right. So on these, what's the range of sine? What's the range of sine? What output values can I get for sine? -1 to 1. So now if I switch x and y, the now domain is -1 to 1. All right. Same thing with cosine. And then what's the range of arctan or tangent? I mean, tangent goes everywhere, right? And so my domain can handle everything for arctan because why? It's a switch in x and y. Now the range part is the one that I need to talk about. All right. If we look at sine, let's just do sine for now. Sine starts where? At 0, right? And then it goes which way? Up, and then it goes down and so forth, right? And so this one's at pi over 2 right there. Everybody agree with that statement right there? Now, to be an inverse, do you remember what tests it has to pass? A vertical line test and a what? Horizontal line test. Now, it passes a vertical line test here, true? However, to have an inverse, it also has to pass the vertical line test. What happens as you go past pi over 2? It fails the horizontal line test. Do you see how that worked? Now, if I were to go backwards, the sine function does this, yeah? And then right here, I'm going to call this negative pi over 2. Does that make sense? And so past negative pi over 2, guess what it fails again? The horizontal line test. So that's why the range is negative pi over 2 to pi over 2. You see how that worked? Okay? That is me proving you why that is the way it is. Okay? All right. Now, for arc cosine, well, let's talk about cosine real quick. Where does cosine start? 1. All right? And then it does what? Goes down and then like that, right? And then this right here is pi. What happens as I go past pi? It fails the horizontal line test. So that's why the range is between 0 and pi. Make sense? All right. And then arctangent. Let's just prove it while we're at it. Oh, why not? So tangent goes like this. True that? We're comfortable there? However, it just keeps doing that little x cubed almost over and over. After we go past pi over 2, it starts failing the what again? It fails the vertical, true that, and it's also going to fail the horizontal. All right? And so that's why the range is between negative pi over 2 and pi over 2. All right? So this is the way I want you to think about it. I always go back to the unit circle on trig. All right? And so this is 0, true? This is pi over 2, yeah? This is 3 pi over 2, but I need you not to think of 3 pi over 2, because if we talk about 3 pi over 2, I'll use this little thing because I'm recording. If I go to 3 pi over 2, it's right here, true? And it's going to fail the horizontal line test by 3 pi over 2. So I can't think of it like that. I need to think of this as negative pi over 2. All right? So arc sine is, yeah, it's the first and fourth quadrant, but it's really from negative pi over 2 to pi over 2. This is something good to write down. All right? And then arc cosine would end up being between what? 0 and pi. So it's the first and second quadrant. Arc cosine actually is quite well behaved. All right? And then arc tangent is the same thing as arc sine. It's in between negative pi over 2 and pi over 2. All right? Those are the answers that we can get. Here we go. Let's start evaluating. All right? So now I have arc sine of negative 1/2. This is the way I want you to read them. Just like when you had geometry, it really solves for angles. So this is the way I want you to read it. Instead of saying arc sine of negative 1/2, say when does sine equal negative 1/2? That's how I want you to kind of read this. All right. So when does sine equal negative 1/2? Now, arc sine is in between what? Negative pi over 2 to pi over 2. So it's in between there. So when is sine negative 1/2? It'd be right here, true? So what is that? What angle is that? I can't say 11 pi over 6. All right, if you put that on a quiz or a test, I'll give you half credit. However, I'm not giving you full because what's in between? It's in between negative pi over 2 and pi over 2. So what answer do I have to have here?
Negative pi over 6.
Negative pi over 6. All right, we can't have 11 pi over 6 because it fails either the vertical or horizontal line test depending on which function we look at, sine or arc sine. All right, let's look at this next one. We have arc cosine of square root 2 over 2. So let's think about arc cosine. What's it in between? 0 and pi. So when does cosine equal square root 2 over 2? It's not a trick question. Cosine deals with what value? X. So when does x equal square root 2 over 2? Pi over 4. There it is. We're done. All right, cool. All right, make sure we understand this. Let's do it again. So let's say arc cosine of, let's say, negative square root 3 over 2. Why not? All right. So what's arc cosine in between? 0 and pi. All right. So when is cosine negative square root 3 over 2? It's not pi over 6, but 5 pi over 6. Cosine deals with x. So we're at 5 pi over 6. All right. See how that works? Yeah. All right, cool. Let's do the next one. So now we have arc sine of negative square root 3 over 2. What's arc sine in between? Negative pi over 2 to pi over 2. So there, that's where we're at. All right. So then, when is sine negative square root 3 over 2? Down here.
So, negative 5.
I can't call it 5 pi over 3. If you give me that, I'll give you half credit. It's really negative pi over 3. All right. Now, I wanted to prove that just because it's a negative doesn't mean the answer's negative. All right. Here's a little trick. If this is negative on sine and tangent, your answer is going to be negative. However, on cosine, on arc cosine, is it ever going to be negative? No. Never, because it's in between 0 and pi. You following me? All right, let's look at this next one. This was a little tricky trick. All right, so arc sine of 2. So when is sine 2? Is sine 2 ever? I'm in between here, but is sine ever going to be 2? No. What's the maximum sine can be? 1. So this one doesn't exist. Can't do it. All right, pretty good. All right, I'd like you to make sure you know how to use your calculators. All right. What mode are we in when we evaluate these things? Radians. Why? Because there's no degree sign. All right. All right, so hopefully we got all of our outputs. All right, make sure we're in radian mode and we get these outputs. Why doesn't arc cosine of 2 work? Why not? Because it's in between what? It's not in between negative 1 and 1. All right, I can't actually do that one. All right, pretty good. All right, let's talk about inverse operations of each other for a sec. All right, if I add something, what's my inverse operation? Subtracting. If I square something, what's my inverse operation? Square root. If I tangent something, what's my inverse operation? An inverse tan or an arctan. All right, that is the inverse operation. All right. However, we always need to be worried about the range and domain constraints of these things. All right. Does that make sense? All right. Remember, the f of f inverse is equal to x. Remember doing that in chapter 1, section 9? Remember that? All right. So anyway, it comes back again. It comes back. All right, so here we go. Let's look at it. So now we have tangent of arctangent of negative 5. Now, do I have any restraints with arctangents?
Yeah, it can't go beyond.
Arctangents are pretty useful. We can actually input anything into an arctangent, and we'll get what we get. We'll give it out what we started with. So if I tangent an arctangent, Guess what I get left with?
Negative 5.
-5. And we're done. All right. All right, let's look at this next one. This is more likely of how I will start asking questions on it. So I'm going to have arc sine of 5 pi over 3. Arc sine of 5 pi over 3. So we'll show you two ways to Tampa. All right. So what's the sine of 5 pi over 3? Good. So now I have an arc sine of negative square root 3 over 2. So now when I think of arc sine, it does have a range restriction. What's the range restriction? That's the domain. So negative pi over 2 to pi over 2. So when is sine negative square root 3 over 2? Negative pi over 3. All right. So that's the way to kind of go about that problem. Now, 5 pi over 3, arc sine of 5 pi over 3, if you just cancel them out, you get 5 pi over 3, true? Mm-hmm. However, you have to remember that arc sine's only in between what? Negative pi over 2 to pi over 2. So you can't think of it as 5 pi over 3 because it fails the test. All right, it fails the vertical and horizontal. All right, let's look at part C. I don't think I'm going to give you a tricky one like this, but let's look at it. So I have cosine of arc cosine of pi. Can I evaluate arc cosine of pi?
I don't think so.
You can't, all right, because it's more than what? 1. So this one doesn't exist, all right? I can't even arc cosine it, so I can't cosine that part. Okay, does that make sense? All right. Let's draw some triangles. All right, what does trigonometry mean again? Measure of triangles. All right. So now I have tangent of arc cosine of 2/3. So let's look at arc cosine. Which two quadrants can I draw this in? 1 and 2. All right. I can draw this in 1 and 2. So these guys are no longer good to me. Arc cosine's positive. So which one am I drawing it in? I'm drawing it in quadrant what? 1. All right. What is cosine? Call. What's cosine? Adjacent over. Oh my gosh. Adjacent over hypotenuse. So my adjacent is 2. My hypotenuse is 3. How do I solve for my other side? I use what? I use Pythag. Can we do it in our noggin? What is it?
13. Square root 13.
9 plus 4 is 13, and then the square root of
Square root of 5.
All right. 2 squared plus b squared is equal to 3 squared. Yeah? All right. 3 squared is?
9.
2 squared is?
4.
Subtract it. You square root. You get what?
Square root of 5.
Awesome. Is it positive?
Yes.
How do you know that?
Because there's no negative.
Because it goes up. Because it goes up. All right. So now that I have my triangle, it's pretty easy. Now let's do the tangent of that thing. So what's tangent? Opposite over adjacent. So what's my opposite? Square root of 5. What's my adjacent? 2. And we're done. I like these. I know. Let's do it again. All right, so now I have cosine of arc sine of negative 3/5. Cosine of arc sine of negative 3/5. Well, arc sine's in between what two quadrants?
1 and 4.
1 and 4. So these two are no longer good to me. Yeah? All right. So, do I draw my triangle like that?
No.
Yes.
Don't you dare. All right, so now, which quadrant is it? It's in the 4th quadrant. Why is it in the 4th quadrant?
It's negative.
Negative. So now I end up having what sign? Opposite over hypotenuse. All right. So now I have a negative 3 there. I got a 5 there. We need to solve for my other side. So what's my other side? 4. That one literally is 4. All right. All right. So now that I have my triangle, now let's evaluate cosine of it. So what's the cosine?
Adjacent over.
4 over 5. Pretty good. All right, we're going to freestyle one. Let's make one up. Alyssa, what trig function you want? sine. So we're going to have an arc sine of what? Okay. All right, we'll do cotangent of it, sure. We'll do cotangent of an arc sine of what? Give me some numbers.
Square root.
Give me some numbers. 6 over 7. I like it. 6 over 7. It's a beautiful number. Beautiful number. All right. So now I have cotangent of arc sine of 6 over 7. Perfect. All right. So arc sine, what two quadrants is available? 1 and 4. So which one is this one going to be in? 1, because it's positive. All right. So what's arc sine? What is sine? Opposite over hypotenuse. So my opposite is 6. My hypotenuse is 7. How do you solve for the other side? It's 5. 5, 6, 7, right?
Square root of 13.
So we get what?
Square root of 13.
Square root of 13. 49 minus 36, square root it, right? Square root of 13. Is it positive or negative? Why?
Because it goes right.
Because it goes right. What's cotangent? Ayo. So what's my A?
Square root of 13.
What's my O?
6.
And we're done. All right. Pretty easy after you draw your triangle. All right, cool. Let's keep going. All right, so now we're going to have some variables in it. All right. So now I end up having sine of arc cosine of 3x. Sine of arc cosine of 3x. Don't worry about the domain restriction. That's not necessary. I mean, it is, but it's not. All right. How do you make anything a fraction? Beyonce told you how to do this. Put a 1 under it. Put a 1 under it. All right. So arc cosine. Cosine is what? Adjacent over hypotenuse. So what's my adjacent? 3x. What's my hypotenuse? 1. Beyonce told me that. All right. Now I need to solve for my other side. So now I have the quantity of 3x squared plus b squared is equal to 1 squared. All right. So what is 1 squared? 1. What is the quantity of 3x squared? 9x squared. So what am I going to do with that? Subtract it. So now I have minus 9x squared. Make sense? And then what do I need to do? I need to square root it. All right. So my other side is the square root of 1 minus 9x squared. I'm going to share where students miss points. Guess what they say? 1 minus 3x squared. Guess what they forget to do?
Take it out of the.
They forget to distribute that squared. Does everybody hear me? All right, make sure you do that. Or you can just leave it in the parentheses. I don't even care. So if you say the quantity of 3x squared, I'm cool with that. But can I just accept 3x squared? No. Okay, I have to use my pen. I don't want to use my pen. Does everybody hear me? All right, cool. All right, so now I have this triangle. So now what's being asked of it? The sine of it. So what's the sine of it? So the opposite over the hypotenuse. So what's the opposite?
Square root of 1 minus 9x squared.
There it is. All right. Pretty simple. All right, cool. Let's look at this next one. So now I have cotangent of arc cosine of 3x. Cotangent of arc cosine of 3x. It's the same triangle. So what are we going to do? It's this, we're just finding the cotangent of it. All right, so what's the cotangent? Hey-o, so what do we have? 3x over square root of 1 minus 9x squared. All right, and so what do we have to do? Because we're in pre-calc, we have to do what? We have to rationalize it. So we end up having 3x times the square root of 1 minus 9x squared over 1 minus 9x squared. All right, and we can't go any further than that. All right, pretty good? All right. That's all I got for you. We've finished our chapter. All right, so there is your homework.